Hello, good day. Today we are going to learn about time value of money. We shall discuss the role of time value in finance to understand the mechanics of how money grows over time. The content in this video covers simple and compound interest, future value, present value, compounding, discounting, and the basic patterns of cash flow. Since this is an undergraduate introductory level finance module, I would encourage you to build your foundation and strengthen your theoretical knowledge by learning how to compute with formula. Understanding why the formula is in such a way will be helpful for you to advance to higher level of study and solving more complex financial problems in future. I hope that at the end of this learning session, you will understand the mathematics of the time value of money as well as to apply the underlying financial arithmetics. Let's learn together. In finance, there is probably no single concept with more power or applications than the time value of money. In fact, of all financial concepts, time value of money is the single most important. Time value of money techniques are widely used in personal and business financial planning. At personal level, you can use them to calculate the value of savings at a given future date, to estimate the amount you need now, to accumulate a given amount in future. You can also apply them to value lump sum amounts or streams of periodic cash flows, as well as to calculate the interest rate or amount of time needed to achieve a given financial goal. Time value analysis has many applications in business, including valuing stocks and bonds, setting up loan payment schedules, and making corporate decisions regarding investing in new plant and equipment. To conclude, mastery of time value of money concepts and techniques is essential for investment analysts. Let me ask you a question. Which would you prefer? 1,000 today or 1,010 years from today? Why? The answer to my earlier question is here. Common sense tells us to take the 1,000 today because we recognize that there is a time value to money. The immediate receipt of 1,000 provides us with the opportunity to put our money to work and earn interest. According to Pi and Neil, money received in the future is usually worth less than today because it could be invested to earn interest over this period. According to Rose, a dollar in hand today is worth more than a dollar promised at some time in the future. On a practical level, one reason for this is you could earn interest while you waited. So a dollar today would grow to more than a dollar later. A timeline is a graphical representation used to show the timing of the expected cash flows associated with a given investment. It is usually a horizontal line. However, it can be drawn vertically too, especially when you are using Excel for financial modeling. For a horizontal line, the time zero appears at the leftmost and the future periods are marked from left to right. The positive values represent cash inflows and the negative values represent cash outflows. Timeline is an important tool used in time value analysis. It is essential first step in organizing and solving financial problems. Even experts use them to analyze complex finance problems. I strongly encourage you to use these concepts. It is very helpful to begin solving time value of money problems by first drawing a timeline on which you position the relevant cash flows. The intervals from 0 to 1, 1 to 2, 2 to 3, and 3 to 4 are time periods, such as years or months. Although the periods are often years, periods can also be quarters, or months, or weeks, or even days. Note that each tick mark corresponds to both the end of one period and the beginning of the next one. Time 0 is today, and it is the beginning of period 1. Time 1 is one period from today, and it is both the end of period 1 and the beginning of period 2. As shown in the timeline, time 2 is 2 periods from today. It is the end of period 2 and the beginning of period 3. What is interest? Interest is the money paid or earned for the use of money. What is principal? Principal is the original amount borrowed or lent. Simple interest is the interest earned only on the original principal amount invested. With simple interest, the interest is not reinvested, so interest is earned each period only on the original principal. The formula for calculating simple interest is shown in the slide. Compounding the interest means earning interest on interest. Compound interest is the interest earned on both the initial principal and the interest reinvested from prior periods. In this example, the principal is 100,000. The interest rate is 5% per annum. The simple interest is 100,000 times 5% and equal to 5,000. The simple interest earned is the same throughout the 5 years. For compound interest, the interest earned increase from year to year. The balance at the end of year 5 is higher when interest is compounded. This is because interest is earned on the reinvestment of previous interest payments. Future value is the amount of which a cash flow or series of cash flows will grow over a given period of time when compounded at a given interest rate. It is the value at a given future date. On the other hand, present value is the value today of a future cash flow or series of cash flows. It is the current worth of future cash flows. Present value can also be described as the amount of money that would have to be invested today at a given interest rate over a specified period to equal the future amount. How do we calculate present value and future value? The future value is found by applying compound interest over a specified period of time. Compounding is the process of accumulating interest on an investment over time to earn more interest. The present value is found by discounting cash flows. Discounting is the process of finding the present value of a cash flow or a series of cash flows. Take note that discounting is the reverse of compounding. There are four basic patterns of cash flow: single amount, annuity, mixed stream, and perpetuity. In the next few slides, we are going to calculate the future values and present values of single amounts, annuities, mixed streams, and perpetuity respectively. Single amount is a lump sum amount either currently held or expected at some future date. For example, invest 1,000 today or receive 5,000 at the end of 10 years. The general equations to calculate future value and present value for single amounts are shown in the slide. Let's look into an example. Consider a person who deposits $100 into a saving account. If the interest rate is 8% compounded annually, how much will the $100 worth at the end of a year? The $100 initial deposit will have grown to $108 at the end of the first year. This first year value is the same number that we would get if simple interest were employed. What if we leave the $100 on deposit for 2 years? Going to the end of the second year, the $108 will become 116.64, as $8 in interest is earned on the initial $100 and 64 cents is earned on the $8 interest credited to the saving account at the end of the first year. In other words, interest is earned on previously earned interest. At the end of 3 years, the account will be worth $125.97. Consider a person who wishes to deposit some money in saving account. The interest rate is 8% and compounded annually. How much should the person deposit today in order to achieve $125.97 at the end of 3 years? We can use the present value formula, which is simply the reverse of compounding, to find the amount to deposit today. An annuity is a series of equal periodic cash flows at fixed intervals over a specified time period. Examples of annuities include pension plans that give retirees a fixed annual payment or loan with fixed and periodic installments. These cash flows are usually annual, but can occur at other intervals such as semi-annually, quarterly, or monthly. The cash flows in an annuity can be inflows or outflows. There are two basic types of annuities. For an ordinary annuity, the cash flow occurs at the end of each period. For an annuity due, the cash flow occurs at the beginning of each period. An ordinary annuity has a first cash flow that occurs one period from now. An annuity due has a first cash flow that occurs immediately. In this example, annuity A is an ordinary annuity, and annuity B is an annuity due. Although the cash flows of both annuities total 5,000, the annuity due would have a higher future value than the ordinary annuity, because each of its 5 annual cash flows can earn interest for 1 year more than each of the ordinary annuities cash flows. In general, the future value and present value of an annuity due are always greater than the value of an otherwise identical ordinary annuity. This slide shows the formula to calculate the future value and present value of an ordinary annuity. A stands for the cash flow, I is the interest rate, and N is the number of time period. This slide shows the formula to calculate the future value and present value of an annuity due. How different is the formula of annuity due as compared to ordinary annuity? Are the formula the same? No. Annuity due can earn 1 year extra interest as compared to ordinary annuity. The formula of annuity due is multiplied with 1 plus I as compared to the formula of ordinary annuity. Here is another way to express the formula of annuity. We can use this formula to calculate the present value of an ordinary annuity. In this formula, C stands for cash flow, R stands for interest rate, and T stands for time period. This formula is given in the formula list of your final exam. With this formula, we can compound the present value of annuity by the number of periods to find the future value of annuity. Here is an example for annuity. I hope you can make use of the 4 formulas given in the slides to calculate the future value and present value of both ordinary annuity and annuity due. The answer is highlighted in yellow. Happy trying? A mixed stream is a stream of unequal periodic cash flows that reflect no particular pattern. The cash flow pattern is uneven and not constant. The amount varies from one period to the next. It is not an annuity. Let's try an example for mixed stream. In this example, an investment project requires an initial investment of 10,000. The future cash flows are 3,000, 5,000, 4,000, 3,000, and 2,000 over the next 5 years, as shown in the timeline. To calculate the future value of the mixed stream, we have to calculate the future value of each cash flow one by one by multiplying the cash flow with 1 plus I power of time. Here we are actually using the compounding methodology. Then we sum up the future value of each cash flow. To calculate the present value of the mixed stream, we have to calculate the present value of each cash flow one by one by dividing the cash flow with 1 plus I power of time. Here we are actually using the discounting methodology. Finally, we sum up the present value of each cash flow. The final answer for future value and present value of the mixed stream are highlighted in yellow. I hope you will try out. Perpetuity is a stream of equal payments at fixed intervals expected to continue forever. It is an ordinary annuity with an infinite life. In other words, perpetuity is an annuity that never stops providing its holder with a cash flow at the end of each year. The cash flow payments or receipts continue forever. The first cash flow occurs one period from now. The present value of perpetuity can be calculated using the listed formula. Let's look into an example. How much would I have to deposit today in order to withdraw 1,000 each year forever if I can earn 8% on my deposit? The answer is 12,500, which is calculated by dividing the cash flow with the interest rate. I hope you have learned something from this video. See you and goodbye.